Hello students, let us continue the session on rational numbers. In our previous session, we had discussed the properties of rational numbers. We have learned closure property, we have learned commutative property, we have learned associative property, we have learned distributive property, we have learned the existence of additive identity element, we have learned the existence of multiplicative identity element, we have learned the existence of additive inverse, and we have also learned the existence of multiplicative inverse. And I have also mentioned that in your textbook, the additive identity element is discussed as the role of 0. This multiplicative identity element is the role of 1. Additive inverse can also be regarded as negative of a number. The multiplicative inverse is also be regarded as reciprocal of a number. Having learned these properties, let us answer a few of the questions. We'll start with the question, is every rational number a natural number? Every natural number is a rational number, but a rational number need not be a natural number. We know that 1 can be expressed as 1 upon 1, 2 can be expressed as 2 upon 1, 3 as 3 upon 1, and so on. In other words, every natural number n can be written as n upon 1, which is the quotient of two integers, n and 1. If you look at the definition of a rational number, it has to be in p by q form, where p and q both are integers and q is not equal to 0. In this particular case, the denominator is not equal to 0 because it is equal to 1. So every natural number is a rational number. And very clearly, the numbers like 3 by 2, 2 by 5, 1 upon 7, 15 upon 20, these are the rational numbers. They are not natural. Hence, we can say that every natural number is a rational number, but a rational number need not be a natural number. Next question, is 0 a rational number? Yes, 0 is a rational number. We know that the integer 0 can be written in any one of the following forms, like 0 by 1, 0 by minus 1, 0 by 2, 0 by minus 2, 0 by 3, 0 by minus 3, and so on. In other words, I can write 0 as 0 upon b, where b is a non-zero integer. Thus, 0 can be written as a by b, where a is 0 and b is non-zero. In other words, it is clearly in the form of p by q, where p is 0 and q is not equal to 0, Thus, we can say that 0 is a rational number. The next question is every rational number an integer? Every integer is a rational number, but a rational number need not be an integer. The explanation goes as with the natural numbers. We know that 1 can be written as 1 upon 1, 2 as 2 by 1, 3 as 3 by 1, 4 as 4 by 1, and so on. In this case, I have taken all positive integers. The same goes with the negative integers also. Minus 1 is negative 1 by 1, minus 2 is negative 2 upon 1, minus 3 is negative 3 upon 1, minus 4 is negative 4 upon 1, and so on. In other words, any integer a can be expressed as a upon 1, which is a rational number. Thus, every integer is a rational number. Clearly, when I look at the examples like 3 by 2 minus 5 upon 3, etc., they are the rational numbers. They need not be an integer. They are not integers. Hence, every integer is a rational number, but a rational number need not be an integer. Next important question, is every rational number a fraction? Every fraction is a rational number, but a rational number need not be a fraction. Let a by b any fraction, then a and b, they are natural numbers. Since every natural number is an integer, therefore a and b are integers also. Thus, a fraction a by b is a quotient of two integers in that b is not equal to 0. So it's clearly a p by q form where q is not equal to 0. Hence, a by b is a rational number. When we look at 2 upon negative 3, it is a rational number, but it is not a fraction because its denominator is not a natural number. Since every mixed fraction consisting of an integer part and a fractional part can be expressed as an improper fraction, which is quotient of two integers. Thus, every mixed fraction is also a rational number. Hence, fraction is a rational number, but every rational number need not be a fraction. Let us try to differentiate the rational number as a positive rationals and negative rationals. What is a positive rational number? A rational number is said to be positive if its numerator and the denominator are either both positive integers or both negative integers. In other words, a rational number is positive if its numerator and denominator they have the same sign. Each of the rational numbers, say 1 by 4, 2 by 9, minus 7 by minus 11, minus 3 by minus 13, plus 5 by plus 12, they are all positive, but 2 by minus 5, minus 3 by 10, minus 4 by 7, 11 by minus 23, they are not positive rational numbers. Then what are these negative rational numbers? A rational number is said to be negative if its numerator and denominator are of opposite signs, such that one of them is a positive integer and the other is negative integer. In other words, a rational number is negative if its numerator and the denominator they are of opposite signs. Each of the rational numbers like -1/6, 2 by -7, -30 upon 11, 13 by -19, -15 by 23, they are all negative rational numbers, but -11 upon -18, 2 upon 5, -3 upon -5, 1 upon 3, they are not negative rational numbers. Let us discuss about equivalent rational numbers. We will learn how to find the equivalent rational numbers by multiplication and division. Let us first learn equivalent rational numbers by multiplication. If a by b is a rational number and m is non-negative integer, then a into m by b into m is a rational number equivalent to a by b. Let's look at an example. 12 upon 15, 20 upon 25, -28 upon -35, -48 upon -60, they are all equivalent rational numbers of 4 by 5. If 4 by 5 is multiplied by 3 by 3, we get 12 upon 15. Multiplied by 5, we get 20 upon 25. If the same is multiplied by -7, we get -28 upon -35. If the same is multiplied by -12, we get -48 upon -60. Each time we multiply with a non-zero integer to both numerator and denominator, we get equivalent rational number to the given rational number. Let's look at equivalent rational numbers by division. If a by b is a rational number and m is non-zero integer, then a divided by m upon b divided by m is a rational number equivalent to a by b. For example, if I consider 20 upon 25, if I divide both numerator and the denominator by 5, I get 4 upon 5. So 20 upon 25 is equivalent rational number to 4 upon 5. Let us solve this question. Find two rational numbers equivalent to 3 upon 7. Let me write the given rational number 3 by 7. Now to find the equivalent rational number, I need to multiply both the numerator and the denominator by a non-zero integer. Say 4 is multiplied, I get 12 upon 28. This is one of the rational number which is equivalent. To find the one more, let me multiply this time with a different non-zero integer. Suppose if I multiply by 11, I get 33 by 77. So the two equivalent rational numbers are 12 by 28 and 33 upon 77. Next question. Determine the smallest equivalent rational number of 210 upon 462. 210 and 462, both these numbers are even numbers. Hence, I divide by 2. If I divide by 2, I'll be getting 105 upon 231. The sum of the digits here is 6 in the numerator and 6 in the denominator. Both these are divisible by 3. So let me divide by 3. What if I divide by 3? I get 35 upon 77. And it's very clear that both these numbers are divisible by 7. On dividing by 7, I get 5 upon 11. And further, I cannot divide and simplify further. Therefore, the least equivalent rational number of 210 upon 462 is 5 by 11. Next question. Write each of the following rational numbers with positive denominator. They have given 3 upon negative 7, 11 upon negative 28, minus 19 upon minus 13. In order to express a rational number with positive denominator, we need to multiply its numerator and the denominator by negative 1. Therefore, this 3 by negative 7, I will multiply 3 with negative 1 and negative 7 with negative 1, so that the denominator will become positive 7 and the numerator will change to negative 3. 11 upon negative 28, I'll multiply 11 with negative 1, negative 28 with negative 1, I'll be getting negative 11 upon positive 28. And negative 19 upon negative 13, I'll multiply negative 19 with minus 1 and negative 13 with minus 1. What I get is positive 19 upon positive 13. If you look at all these numbers, they have got the denominator as positive number. One more question. Express negative 3 upon 7 as a rational number with the numerator as negative 15 and positive 21. So first one, in order to change this negative 3 as negative 15, I need to multiply some number to both numerator and denominator. I'll write the given number as minus 3 by 7. Now, what I require is negative 15 in the numerator. So what should be multiplied to get negative 15 in the numerator? It has to be 5. So 5 is multiplied to negative 3, we get negative 15. If 5 is multiplied to 7, we get 35. So minus 15 by 35 is an equivalent rational number of minus 3 upon 7. Second one, what should be multiplied to get positive 21 in the numerator. We know that when negative 3 is multiplied to negative 7, I get positive 21. If negative 7 is multiplied to positive 7, it becomes negative 49. So both the numerators are now changed to negative 15 and positive 21. Hence, these are equivalent rational number to minus 3 by 7. With this question, I'll end today's session. We shall discuss few more forms of equivalent rational numbers in the next session. Thank you.